Hello everyone, this is Singh 𝐂𝐤 and today we are focusing our discussion on how Discord handles millions of concurrent voice users. So if we talk about Discord, we already created two videos specific to system design, like how it stores billions of messages, then how it indexes those billions of messages. Today we are focusing on like when you create a channel, there could be some voice discussion going on, right? You can join the discussion and have the discussion with the channel members. So how these members can interact with each other, what's the backend architecture looks like, how this system scales for those millions of customers, we are deep diving into that. So let's start. Before that, our channel is MsDeep Singh, so if you are not subscribed yet and you are new to the channel, consider subscribing. We keep on discussing these kind of content. We analyze large scale systems, we specifically focus on how can you design large scale systems, so consider subscribing. Moving on, so before starting our discussion, there are two main points, like how this communication can happen, right? So there can be two ways how people can interact on this channel. When we say this channel, right, I will give you some basic terminology if you are not aware of Discord, right? So let's say this is Discord application. Now on Discord, spelling is incorrect, okay, it's correct now. So on Discord you can create server. By server we mean you can create your own, let's say, organization where people can come in and join various channels you created, right? So this is your Discord server, which let's say is named MsDeep Singh. And now we have various discussions which happen on our YouTube channel, let's say, right? So on basis those topics, I can create channels on my Discord server. Let's say system design. System design is one channel, then another channel is cloud, right? And there can be also one-to-one peer-to-peer connection, when we say peer-to-peer chats, right? So there can be two users who can interact directly. So there can be users who communicate directly with other users who are part of that server, right? So these are the things which you can do when you use the Discord application. So you joined MsDeep Singh server, and then you can connect with other users which are present on this server. Also there can be channels which can be specific to topics which we discuss on our YouTube channel. It's confusing. YouTube channel with Discord server, but let's say these topics map to Discord channels, right? So when people interact on these, how that communication can happen, right? So first way is peer-to-peer connection, and another one is client server architecture. So when we say peer-to-peer architecture or peer-to-peer connection, what we mean is we have two users. This is user 1, okay, and this is our user 2. So these users are interacting with each other directly. We don't have anything in between, any server in between. They are interacting directly with each other. This is computer of user 1 and this is computer 2 of user 2. So they are interacting directly. There are no third party in between. They are interacting directly. This computer is sending any network packet this to laptop which is associated to user 2, and it is sending back. So the communication is happening directly with what we by mean is peer-to-peer connection, right? Another one is client server connection, client server architecture. So this is like you might have studied in college as well. So what happens is we have two users, user 1 and user 2, and they communicate in between via a server. So there could be a server, in this case a Discord server, right? We are interacting on Discord application. This could happen on any of the applications you use, right? Let's say Facebook, you use Facebook Messenger. So two people are interacting. How they are interacting, your message will go to Facebook server and then it will be directed to user 2, right? So this let's say I send let's say hello to user 2, so it will be sent to Discord server and then it will be delivered to user 2. Similarly, if user 2 sends any message, it will be first communicated to Discord server and then it will be forwarded to user 2. So this is what there are these two ways how you can communicate with the users. Now Discord is using second option. Discord is using a server in between. Discord is using client server architecture. Now why it is using it, there could be certain reasons, right? We choose a particular design, we choose a particular system, or we choose a particular way we are designing the system, and there are some reasons associated to. We did weighed some pros and cons, and according to those pros and cons we decided that we want a server in between multiple users. Let's say you have user 1, user 2, and I want a server in between which will help communicate these users. So there are certain reasons. What are the reasons? One is peer-to-peer networking becomes expensive as number of users increases. Number of users are increasing, then what happens is expensive. By what means by expensive, what we mean is ज़्यादा पैसे लगते हैं ज़्यादा पैसे नहीं लगते. What we mean is कि it's hard to manage. The latency increase subsequently, like in a very high number, and you can't expect a latency increase when two people are interacting, right? When I send you a hello, you don't expect that hello to arrive to you after 5 minutes, right? You want that instant communication in place. And how can you do that? It's not possible via peer-to-peer connection, peer-to-peer communication. It becomes kind of impossible. You can do it obviously, but it's not kind of that much of scalable, and we are looking here to the millions of users. Peer-to communication can work probably to 10 users, 20 users, to a good extent with a very less latency, right? But if we are scaling beyond that, then this becomes a bottleneck. So it's the main reason. Definitely there are certain added benefits apart from this low latency which you can avoid by using low latency, which you can achieve by using client server architecture. So another benefits are routing network traffic via Discord server ensures that user IP is never leaked. So when you are interacting with this peer-to-peer connection, right? This is your 1 and this is your 2. So this 2 knows your IP address. So this user 2 can launch a DDoS attack on your IP address, right? But if there is a server in between, you don't know what IP this request came from, right? So you are abstracting that user from another user. So this is a kind of a security feature you get when you use client server architecture. Third point is moderation. When we say moderator, so coming to this example only, let's draw it again. So this is your computer 1 and this is your computer 2. When we say moderator, we said we have a Discord server in between, right? So this Discord server also acts as a moderator, right? Now what moderator can do is, the admins which on a particular channel, there will be certain admins who have access to mute or drop off those offending users on the channel, right? We don't want anything fishy going on this channel. So what these admins can do is they can remove those members, or they can mute those members for a time being. There can be certain warnings, like anything of that sort can be developed on it via using moderation. So these are the kind of benefits we are looking at when we use client server architecture, and Discord uses it to scale for millions of customers which interact on these voice channels. Okay. Now moving to client architecture, how this application looks like from client perspective. So Discord uses webrtc. Webrtc is web real-time communication. It's a protocol which is used inside the web browsers to help you with voice and audio and video functionality inside the web browser without using any native libraries or plugins which you have to install in the web browser. So you can directly achieve that using webrtc. If we talk about the definition from Wikipedia, it's kind of a very huge topic in itself, but we are not focusing on that in this specific video. Probably we'll make another video. You can let me know in the comments below. If we need that, we can discuss that definitely. I will also have to deep dive into it. I have kind of very little knowledge about it. I have some knowledge, but it's not like that I can deliver a lecture on it. So I have to deep dive into it. If you have any resources which you can share with me, definitely that will help. So if we talk about definition from Wikipedia, what it mentions is, by definition, what we mean is what kind of functionality you can get by using WebRTC. Okay, so it provides web browsers, mobile apps with real-time communication via APIs, right? We want a real communication. There are APIs exposed by this protocol WebRTC, which we can use to provide real-time communication. It allows audio video communication to work inside web pages by allowing direct peer-to-peer communication. So this is the key point. this is the key point. So it provides real-time communication via APIs, and it's peer-to-peer communication, eliminating the need to install any plugins and download native apps. You don't need any server in between. You don't want any moderating library in between that can help to get this connection working. It directly works peer to peer. But what we discussed some time back is Discord uses WebRTC, but it's not using peer to peer communication. So how it's achieving that, so there is a custom implementation of top of WebRTC. We want to use WebRTC because there are some kind of functionality we are interested in, but we don't want the whole package. So what we did was, we will abstract out the WebRTC. Let's say this is an open source project. I will fork into my repository and I will customize it for my use case so that it works for my use case and scale for the customers I am looking at. I have millions of customers. I have to scale for those customers, right? So if WebRTC by default is providing peer-to-peer communication and I see that it's not scaling to that number of customers, what I will do is I will take out this library. I will do some kind of custom implementation on top of it, and it will work for my users. So what kind of custom implementation we are talking about? So these are like basic details. These are the basic details which I took from Discord blog. Let's give it a quick read. We will not go into much details, but let's give it a quick read. What kind of customizations we did? First one is, so WebRTC by default relies on session description protocol to negotiate audio video information between the users. So when we see what we mean is, I will give the quick overview. What we mean here is, so let's say this is your user 1, right, and this is your user 2. So when they are interacting with each other, right, so session description protocol helps to negotiate video and audio information. You are sending some information, right, and you are getting some information, so it helps in negotiating this information, and it's around 10 kb per round trip. The information, right, the audio and video information, it's around 10 kb for round trip. Now how we can optimize it? Can we do it for in first place? If we can do it, how we can do it, and how by how much we can do it? 10 kb can be a huge number for two users interacting. We have millions of users which are interacting, so it will be a huge number, right? So if we can reduce even by 1 kb, let's say from 10 kb to 9 kb, then it will be a huge win for us. So did we do anything about it? Let's go into it. So Discord utilizes lower API WebRTC call to create, send, receive streams and reduce information that can be exchanged. So what information we are exchanging is, there is more information which is exchanged by default by session descriptor protocol. We are using lower API like session description protocol is developed on this, and there are some added functionality. We are not using directly to it. The API which is exposed by the by WebRTC, we are directly implementing on top of it. So the information we are interested in is server IP port, then encryption method and keys, codec and stream identification, right? And it's around 1 kb. Just give me a moment. Yeah, okay. Cool. So we have reduced from 10 kb to 1 kb, right? So the information we are exchanging, it is helping us to negotiate, like the SDP helps to negotiate the audio video information, but we are reducing the bandwidth we are consuming, and it's by a huge number. From like for two particular users we are talking about, like reducing the consumption, like the information which we are sharing from 10 kb to 1 kb, so we are reducing it by a huge number. Going to the second point, WebRTC uses interactivity connectivity establishment, big words, ICE college 3 days वाली याद है क्या? ICE college to determine best communication path between users. Since every client connects to our media relay server, ICE is not readed, right? So what ICE help is, we have again these two handsome users, right? This is what's happening. Yeah, we have user 1 and then we have user 2, right? And now these two handsome users, user 1 and user 2, we need some like path in between, right? So let's say this is your, there are multiple paths, path A, path B, to help to like we have to send some network packets from user 1 to user B. So we want some good path in between so that they can interact with very less latency possible. So IC help in that, but we have media relay server in between, because in case of Discord we don't have peer-to-peer communication, we have server in between, so IC is kind of not needed. But what media relay server helps in, it provides more reliable connection when you are behind net. Also keep your IP secret from other parties in channel, we already discussed that. Client sends ping messages at fixed frontal to ensure firewall remains open. So this is kind of a basic thing, but let's say this is your media relay server MRS, and this is your user 2. So we don't need IC to determine the path. Media relay server will help in that. Apart from that, media relay server will also help into these functionalities. It will help to abstract out the IPs which we already discussed. It will help into reduce, like the user 2 will not know your IP address, so there is kind of security functionality you are getting. The user 2 cannot launch DDoS attacks against you, right? And to keep the connection open, this client will keep on sending ping messages to MRS so that the connection is remained open via firewall. Cool. Moving to the third point, WebRTC uses secure real-time protocol SRTP for media encryption. The encryption keys are set up using datagraph transport layer security, which is based on TLS protocol. You can also implement on transport layer via WebRTC transport API, and this is what we are doing in our case. We are not using the default transport layer security which is being provided. We are using SALSA 20 encryption. There is something wrong with this pencil. Oh, eraser is selected. There is nothing wrong with this pencil. So SALSA 20 encryption is used, and then no audio data is sent in periods of silence, help in saving bandwidth and CPU usage. So these are the two functionalities which we have customized specific to this, right? We have used SALSA 20 encryption. This is one point, but another point which is important is, let's say we have this channel, right? And these are users. We have a lot of users. Let's say right now we have 4 users. So at a time, mostly it happens at a time, not everyone will speak. One person will speak. Let's say this person is speaking and everyone else will be on mute. So do we have to send some kind of audio data in that case? If we determine that only this person is speaking and we can treat them as a mute persons, then we don't have to send any audio data from these users to media server, right? And it helps in saving bandwidth. Definitely it will help in saving bandwidth. Let's say, think about like a million users in a channel, right? And if you are sending audio data for all of them and they are not speaking, right, there can be just kind of a background noise which we don't want to transfer. It's kind of a no use, right? So we are achieving that by not sending the data in case of periods of silence. When we say periods of silence, what we mean is only a single user is speaking. We can determine that who is speaking, and all the users which are not speaking can be the system can think that they are on mute. Even if they are not muted in the application, we can think that they are on mute, they are not speaking, and if anyone starts the communication at that time, we can send the audio data, right? So in this case, how it's helping is it helps in saving the bandwidth and reducing the CPU usage. CPU पहले 99 था, उसको हमने कम करके 10% कर दिया. These are the like random numbers I'm talking about, right? So we discussed the client architecture. Now let's move to how backend architecture looks like. Client, when we say client, how it looks like from the user's perspective. Now from backend, how it looks like from the server's perspective. The servers which are actually helping to carry out this communication between the users. So how this backend architecture looks like. This is the simple point how communication is initiated. So user channel, like user a client on a mobile application or a web browser application will initiate a connection and on a particular channel, right? On a Discord server by from a server perspective, it is referred as guild. Guild is basically a combination of channels and users, which means Discord server. So here when we are using term server, it means the backend machines, right? But from a client perspective, Discord server means guild terminology, not to confuse the people. So some points about backend architecture, how it works. So I will just read through it. Written in Elixir. Elixir is your functional programming paradigm, which is kind of scalable for these kind of use cases when there are millions of customers and they want to interact in real time. Same use cases for WhatsApp, they use Erlang EasyBuddy server, right? So for chat functionality, that is preferred EasyBuddy server. WhatsApp uses the same. So Elixir is kind of similar to Erlang. I think it took the inspiration from that only, right? So it is the Discord server are written in Elixir. Main backend services, we have three main backend services. We have also created short names for them, right? So that we don't have to repeat them again and again. So first one is your Discord gateway server, which is called DGWS. Then we have Discord guild server, which is DGS, and then we have Discord voice server, which is DVS. Moving on. So what happens is, how it works is, when you are online, this your user, we will try to draw and then I will try to explain. We have space here. So first point, second point, starting from second point, you are user, you are online, right? When you are online, this client will maintain a WebSocket connection with Discord gateway. So this is your Discord gateway, DGWS, right? DGS, when we say WebSocket connection, it is bidirectional. If you are not aware about what WebSocket is, we have created a specific video about this which you can refer to get details around polling and how WebSocket works, and you will get the basic understanding what these things mean. So if we talk about in short, WebSocket provides bi-directional communication. User can send some data to server and server can send data to client. Okay, on the same connection. We don't have to create another connection to send the data. It happens on the same connection. So when you are online, when you are the user is online, client maintains a WebSocket connection with Discord gateway. Any event related to guilds, channels, messages, it's sent via this. So this is your WebSocket connection. Now this WebSocket connection helps in any communication which happens between client and the Discord server. Let's say this specific channel, system design. This is your Discord server. The guild which we mean is, when we say guild name is MsDeep Singh. Right, on MsDeep Singh, we have a channel system design, and on this system design, let's say I posted a new video. So I created a post that there is a new video, go watch out on YouTube. So you will have to update all these users which are part of this channel. How this happens via this WebSocket connection, which is maintained with DGWS. Cool, let's rub it. It's kind of messy, right? So clean it out. Cool. Moving to another point. When you join a voice server, you are assigned a Discord voice server responsible for transmitting every member's audio to channel. This will discuss in little bit detail how this Discord voice server is assigned. Cool. Then second point is, all voice channels within guild are assigned same Discord server. It helps in efficient interaction. If you are first voice, they just send Discord voice server. Once you are connected, connection status is represented by voice status. Cool. So how it happens is, I think we have already created it here. Yeah. So these the details are kind of combined here. How it works is, like first you established a web. So this is your first connection you established with Discord gateway server, which helps in like providing any kind of events, messages, which interactions that happen on our guild Discord server. Now, if you're starting a voice chat, if you're starting a voice discussion on this channel and you are the first user to start it, you are the initiator, right? You are the initiator, you are initiated this discussion. So how this actual flow looks like, how it looks like. So this is your user which is online, very handsome user. right. This is your user which establishes a WebSocket connection, which we discussed right now, right? Which helps in all those things, maintaining events and sending messages and all those things. So this is the first thing which we do. Now you are first one to join the voice server. When you are first one to join the voice server, you will send a notification to this Discord gateway server. Like you will make a request to Discord gateway server that I am starting a voice discussion. Right now, Discord gateway server, what it does is it tries to find a Discord voice server from etcd. etcd is a service discovery server discovery service. We discussed this little bit in our last video, so if you haven't checked that out, please check that out. You will get an idea around how etcd works and how it is used to find nodes in case of Elasticsearch, right? So similar functionality we are providing here. etcd is a server discovery service which helps in discovering servers with less minimum load in our system. Cool. So this DGWS Discord gateway server, what will it will do is it will interact with etcd to get a voice server. Once you get a Discord voice server, like let's say this is the voice server which etcd mentioned. So what you will do is you will this uh, Discord gateway service will inform the client that this is your selected DVS. So once you are aware that this is your DVS, when we say DVS, Discord voice server, right? So it will establish another WebSocket connection with this, and all the channels which then like joins this discussion, they will be assigned. They will be connecting to this same DVS, right? The point here. All voice channels within a guild are assigned same Discord server. It helps in efficient interaction with reduced threats since all users are present on same server. So all the voice channels, there could be multiple voice channels inside this guild. All this channels and all the users present on this channel will interact on the same Discord voice server. It helps in reducing the latency, because if there are multiple servers involved, there will be system to system communication. But here, since everything happens on the same system, you will improve that on latency, right? Now how this voice server is assigned, let's discuss those. We already discussed those details, right? But specific that point, uh, one point, how etcd gets the Discord voice server which users can join. So it will figure out what is the least utilized server, and once you figure out that, you will inform the users that this is your DVS and you can connect to this DVS Discord voice server. So after DVS selection, voice state objects are put to DVS so that it knows how to set up audio video forwarding. This is done, clients are notified, and then clients open a WebSocket connection. Cool. And then they can start on their discussion. Now some more details about Discord voice server, how it works internally. So let's discuss those details. So some more details about Discord voice server. It contains two components specifically. So let's say this is your Discord server, a Discord voice server. It will contain two main components. One is signaling component and another one is media relay component. Signaling component helps in controlling the SFU. When we say SFU, it means selective forwarding unit, and it generates stream identifiers and encryption keys forward, like all those things. Let's say let's take a basic example how you can understand this. So let's say this is your channel. Now we have user 1, user 2, user 3, user 4. Now we discussed one point before, that we want to mute all the users which are not speaking, and we don't want to send any audio data to the server in those cases, right? If there is moments of silence and if there is no one speaking, we don't want to send any audio data. So how can you figure out that? This helps here. It gives the speaking indication who is speaking, and by that you can figure out who is speaking, and you can mute all those other users. You don't have to send any audio data for these users. So this is the one example which helps. And Okay. SFU is also responsible for handling real-time control transport RTCP, which is used for audio video quality optimization, collects and processes and notifies senders how much bandwidth is available for video. So you can skip this point, but to give you a basic idea, it also, like for Discord specifically, they use different protocols for audio and video. For audio, we already they are using WebRTC, right? For audio, for video, they are using this real-time control transport protocol, right? Which is used for video quality optimization. Now coming back to the voiceover itself, right? We are not going much into how video works. We are specifically focused on voice today, right? So in case if a Discord voiceover fails, right? Let's say this communication was going on, this was DVS, selected DVS, and all the users are interacting with this, right? What if this server fails? We mentioned that all users are connected on the same server. What if this server fails? Where will these users go, right? We have to find some new server. So how that functionality works in backend, that you are trying to figure out a new server so that they can connect to that new server in a minimum time possible, so that there is no disruption when the discussion there, when there is a real time discussion going on. We don't want to interrupt the user, so it should happen in the minimum time possible. How it works is, so how the failover works. By failover we mean the system is down, that particular DVS is down, right? So the signaling component monitors SFU. SFU definition I forgot. Selective forwarding unit. Selective forwarding unit. So signaling components monitors it, and if it crashes, it is restarted again. Probably it will drop some packets. Definitely it will. Could, when we say could, it is definitely it will drop some packets. Because for a time being the server is down, and state is reconstructed by signaling component. By state we mean that voice state objects which were pushed to that server earlier, they have to be pushed to another server. So this will help here. So Discord voice server died. Let's draw some diagram here. This is your Discord server, this died. Now what happens? Client WebSocket connection is cut. This is your client which was interacting with it, so it is cut with, and it requests voice server ping through gateway WebSocket connection. So when this is cut, DVS this client has WebSocket connection with DGWS, right? We mentioned that there are two WebSocket connection. One is with gateway server and one is with voice server, right? When this is cut, it will interact with DGWS, that I'm not able to send my data packets, right? I'm not able to interact with the voice customers which are present on my channel. How can, please fix it? So what DGS will do is, DGWS will do is, what was DGS? Guild server, right? So this particular user, not with this is the WebSocket connection, but it will interact with DGS, Discord guild server, that please find me a new server where I can connect in. So client WebSocket is connected and request a voice server ping through gateway WebSocket connection. It will confirm with this, right? Once it confirms, DGS confirms failure by consulting with ETC and assigns a new DVS to guild. This DGS will assign with discuss with ETCT. It will have a discussion, brief discussion with ETCT, that there is something going on, something the users are not able to connect, please give me a new server. This ETCT, what it will do is, it will figure out a server with least load, right? This is how it works. We will find out a server with a least load, and then the new server, like all the voice state objects which were present on the earlier Discord voice server, will be pushed to this new server which is figured out via etcd. There is one point which we'll discuss in some time after the fifth one discussion. So every client is notified about this new deviation, creates a voice server into a new voice server and start media setup. Okay, so this is your DVS2 which is figured out, and the users will be notified about it, and they will establish a connection with this. All the voice state objects which were present on this DVS, what's happening on DVS1 which went down, will be pushed to this. We didn't discuss specifically about where those voice state objects are stored, but in earlier video we discussed that Discord uses Cassandra. So probably I don't have concrete details about it, but how I am thinking is probably DVS also maintains this voice state objects on some database. See, since all users are present on this same DVS and they are interacting on the same database, like same server, they don't need specifically a database in place, right? All the information can be present on this and can be exchanged between the users. But in case of downtime, if it goes down, and we need the data, right? Like let's say who all users are present, right? So those voice state objects we need to push to new DVS, to the new server which is figured out by etcd. So in that scenario we have to push this data continuously. Probably it can happen in background. We are not fetching that information for real-time communication, but that information is probably forwarded to Cassandra here, so that in case my server dies, in case of any inconsistency, or in case of any failure or anything, then I will interact with Cassandra and get those voice state objects and push to DVS2. All users will interact with DVS2, and then they can start their communication again, they can start their important discussion again. So this is all about there is one more point. DVS is directly accessible public internet, so it's quite common to suffer DDoS attacks, and same procedure follows in case there is some inconsistency observed on a server. Same procedure in case DVS is brought down intentionally and a new server came up at its place. So this is all about how millions of concurrent voice users interact on Discord servers, Discord channels, and we will be discussing more such content, more such discussions we will have in upcoming videos about how large scale systems are designed and how actual systems you can design. Till then, stay safe, tata, bye bye.